Hi everyone, in this video we're going to create an orthographic 3-view drawing from the given isometric pictorial shown on your screen. This drawing can be found on page 32 of your textbook. It's assignment A11. It's called Link. So the first step that we're going to take is we're going to analyze the object and visualize what the views are going to look like. As you recall, the textbook uses an arrow, so the blue arrow, to show us what the front view is going to be. So in real life, in a real world scenario, you as the designer will be the one that is choosing the front view. Typically students ask, well, how do I choose the front view? Well, there isn't really a right answer to this. It's up to interpretation, but a good rule of thumb is usually the front view shows the major characteristics of the object. So the textbook uses the arrow to remove that decision making so we can focus on learning how to create third angle projection orthographic views. So we've already covered the concept of scale, but I'd like to take an opportunity to further expand our knowledge on this idea of scale, because understanding scale and considering the scale of the object will be a critical step in utilizing our paper space. So what I mean by that is, if you look at your textbook image, which is the same image I have on the screen, you will notice that the object is drawn to a scale, but the scale is not given to you. So how we determine this is that if I look at my ruler and I look at the 3-inch mark and I compare that to the 3-inch dimension on the actual isometric pictorial, I see that the units in real life, my actual units, are larger than what is shown on the drawing. So 3 units in drawing space are smaller than 3 units on the ruler, actual size. So it could be said that this isometric pictorial is drawn at a reduced scale. So for our purposes, we are going to have to scale this object. We have the dimensions that are given in inches. If you look at the title strip at the bottom, the book points out that this is decimal inch dimensioning. So we have the inch sizes of the features of this particular object. So the next thing we want to do is we want to sort of look at our paper, and our paper is a standard, what's called a letter size paper, or another word for it. So it's, I'll write this down, letter size. Letter size. It's also referred to as A size. So these are just different ways to refer to the actual size of our paper. The paper is 8.5 by 11 inches. So I can show you, can prove this to you with my trusty ruler. So we've got approximately 11 inches. And again, this is a nominal size. It's not exactly 11 inches, but this is the nominal size of the paper. And it's not quite 8.5, it's 8.25, but nominal size. So if I were to start imagining 3 views on this sheet, the book is asking you to draw 3 views. Front, right side, top. So we're going to arrange these views in this area of the paper. So we don't want to draw the views really small and have a bunch of wasted paper space. We want to maximize this paper space. So what I'm going to do is, if you go back to the image, for the front view, as indicated by the blue arrow, the working envelope that we have to deal with is about a 3 by 2 inch rectangle. So if I use my ruler to sort of gauge this out, 3 inches, I'll mark it out. I'll just draw a line. Let's draw a 3-inch line, sure. 3 inches, and I'll make this 2 inches. I can tell that the view will fit quite nicely in this sort of quadrant of the page. The top view is similar in size as far as how much paper space it's going to take up. So I'm going to go ahead and just draw a rectangle that represents the front view and the top view, just so I can lay out how it's going to look on the paper. And I'll use these lines as construction lines later. So construction lines are lines that help us draw our views. So they're used in the construction of the drawings. So I'm going to space my views an inch apart. So 4 grid spaces equal 1 inch. And I know the width of my top view, the maximum width of it is the overall width of it is 3 inches as well. Okay, so, and the depth of the top view, you can see on the diagram, is 2 inches. So I'm going to draw another essentially 3 inch by 2 inch rectangle. So there it is. You can count out squares, you can just use your ruler. So there's my top view. My right side view, I'm going to start it 4 squares away, which is 1 inch away. And my right side view is 2 inches overall in height by 2 inches in overall width. So let's just draw a 2 by 2 square. And I will use these rectangles and this square to test out how this looks on paper. It looks pretty good. And I'm not saying that you have to draw rectangles and squares each time. I was more or less trying to demonstrate and show you how this was going to look on the paper. So we've established a scale, and that scale can be expressed as 1:1, as a ratio of 1:1. So 1 drawing unit is equal to 1 actual real life unit size. So it can be said that this drawing is drawn to full scale. You'll hear this type of terminology, full scale. So we can move on now with fine-tuning these rectangles and turning them into an actual shape of each corresponding view. So we now have a scale, full scale. We can move on and draw the rest of the object. So what I've done is I've prepared a model in Inventor just to show you another few angles of this component. So here it is. I'll orbit it around, and we can see that there is a feature on the rear of this object. And so going to the textbook picture, we have to sort of assume, because we're not told otherwise, that this notch out of the back here runs the entire length of the component, because we're not really told that otherwise. So it's okay in this case for this activity to assume that. Now, of course, in real life, if you weren't sure of some information or a feature, you'd want to ask somebody before making an assumption. So back to my model, we are going to create a front view, and it will look just like this, except this view in the software with the view settings I have right now, it's not showing the hidden line that we will also require, the hidden line that represents this edge right inside here. The other thing just to take note of, my Inventor software has what's called a view cube, and it orientates the part within the software environment. Now you see the word left, just ignore this. This view cube is orientated as per how I drew the object with respect to the origin in the model space. It has no bearing on what I choose as my view in the actual layout space of the engineering drawing that I would produce. So just ignore that. That's a software thing. It's not important. So in terms of the textbook, they chose this to be the front view. So that's what we're going to roll with. So my front view will look like this. My side view or right side view will look like this. And the rear would look like that, but we're not drawing the rear. The top will look like so. Just like that. So we'll move on with the drawing. So there is a surface here that is 1 inch in height, and I'll capture that, and you're going to have to read the drawing to determine that this is 1 inch in height. And how I do that is simply looking at the actual drawing, taking the overall height, the 2 inches, and we're just going to subtract away this 1/2 inch thickness, and there's another 1/2 inch thickness here, right, as specified by this dimension. So this is 1/2 inch. So we're going to take the overall, the 2 overall, and we're going to subtract a total of 1 inch, which leaves us with this remaining dimension that's 1 inch. So let's move on. We'll draw the other features on the front view. So our 1 inch, one by half. And then I'll need to remove some construction lines. I'm going to draw this surface. Okay. Clean up my lines a little bit. Try to clean your lines up so you don't have little extensions or anything crossed over. Just try to terminate your lines at nice sharp corners. So I'll erase the remaining construction lines and just leave the necessary visible lines showing. Okay. So there's the front view. Now, students typically, at this stage of the course, they typically can't resist the urge to label this view. You do not need to label the view as the front view. Actually, I'll probably remove marks if you do, because it's not required. Doesn't matter what we call this view. We know that the view that corresponds with this view here, in our case it's the front view, we know that this view is looking at the object from the right side here. So we don't need to label the views. It's actually redundant. So now I'll draw the right side view. Let me refer back to the diagram, and then let's just look at the inventor model. So this is what we will see. The hidden lines aren't shown, so we'll have to make sure we capture hidden lines. Now what I'm going to do next is I'm going to use my front view to project features over to the side view. So my ruler will help me gauge, or the grid lines will help me gauge the features on the right side view. That's the beauty of orthographic projection, is that I can use the corresponding views to help in the understanding of and the communication of the object's features. So now this surface here, I can transfer that over to the object. So there it is. And then there's this other feature that runs along the rear. So we'll notch out this view. I'll remove the hidden or the construction lines. Okay, so that's starting to take shape. And then this raised portion here, we'll take care of that. We'll remove the construction lines. So we're almost there, but we are missing something. Now let's go back to the CAD model. Looks like I didn't use a ruler for that line, but my page is curved up. So trust me, that's a straight line, just the camera angle and the paper being slightly distorted. So back to the CAD diagram. If I rotate the object around, there is an interior feature. This edge and this edge. Let me highlight it with my sketching tool. So this edge and this edge need to be shown as hidden lines on the right side view here. We need to capture that. So we're going to have to show that on our diagram. So we can draw the hidden lines. Now what you want to do with the hidden lines is when you start a hidden line, it should terminate, the first dash should terminate with the adjacent visible lines, so that there's no ambiguity of where the feature starts and stops. Also, when I have a hidden line edge, two hidden line edges meeting, or multiple hidden line edges meeting, I want to terminate those dashes like so. So now with this hidden line, we've captured the interior feature. Let's go back to the model and just look at what we've done. So we've captured that feature with the hidden line. So we have no other hidden lines to show in the right side view. So another thing I want to show you is how to use your ruler to help you error proof. So what you should do is you should use your arrow to, or not your arrow, your ruler to align edges from one view to another to see if you're missing anything. So if I go along here and I run in with my ruler to this edge, which also represents a surface along the rear of the part, I can clearly see here now that I am missing that feature in the front side view. This should be shown as a hidden line. So I'm going to draw another hidden line here. Equally spaced dashes. We're not going to be fussy telling you to draw these in a certain ratio or certain space per dash. Just draw them consistently. Make sure they terminate on the adjacent edges. So let's go back up. This looks good. This looks good. So it doesn't appear that I'm missing anything else at the moment. So we've got our front view, our right side view. Now let's move to the top view. So the top view, and let's look at the CAD model. So this is what the top view will look like. Again, my CAD model is not showing the hidden lines at this particular setting that I have, but it'll give me an idea, just to give you an idea what it's going to look like. So eventually you need to get to a point where you can look at the isometric and work this process to draw and interpret that 3D pictorial in orthographic views. So back to the drawing. I'm going to lay out the rest of the lines. I'm using my ruler to gauge. Me as well, I have the ruler. I have these grid lines. So there are those features. Then there's this raised portion here. And again, this direction or this distance is depth. It's the same distance shown in from left to right in the right side view. So these 4 grid spaces or grid lines represent 1 inch, which is the distance from the rear to where the feature ends. Rear, this is where the feature edge is. 4 grid spaces. And then I need to capture this edge on the top view. So this edge, again, is 1, 2, 3, 4, 5, 6 grid spaces away from the rear. So I'll just lightly write in here, this is the rear of the actual component. That's the rear. So 6 grid spaces away. 1, 2, 3, 4, 5, 6. So right here is where that edge is located. And then I remove the construction lines and clean up my lines. Okay. Try to make them terminate nicely. Get rid of any unwanted marks on it. And then again, looking at my right side view, I need to make sure I capture this edge slash surface on the top view. So this is going to be shown as a hidden line. Okay, so there's my hidden line. Let's go back to the CAD model just to let you visualize it. So let's rotate this around. So here's my top view. I'm just trying to show, not trying to, I'm showing this edge by drawing the hidden line on my model. So that's what that hidden line represents in paper space, or on my paper drawing, I mean. So there it is. So I can use my right side view as a checklist to check that I have all the lines shown on the top view. So this line, so if this is the rear and this is the rear, then I can work backwards. Is this line captured? Yes, there it is. 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 But I'm not finished yet because I have some hidden lines that are still missing from the top view. Let me just erase this so we don't get confused with anything. So let's go back to the CAD model again, and looking at the object, if I were to rotate this edge, let me circle it or highlight it with my little drawing tool. So this edge need to be represented in the top view as hidden lines. So let me draw again. So there'll be hidden lines. Boom, 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 boom. Okay, so let's go back to the drawing and bring this home. Okay, so I believe that looks complete. I can check with my front view for the vertical lines. Looks like I've captured everything, and again, like I said, you can use the right side view as a checklist for the horizontal lines. We'll use a technique later in the course. We'll draw a miter line, and we'll use a miter line to sort of reflect construction lines to allow us to use the top view or the right side view to draw each other. So I'll show you that in a future episode. Okay, so have some practice. So this one was quite simple because we were able to draw this object full scale. Full scale is pretty easy because we can simply, there's no thought process or any math or any ratios involved. We're just drawing the object size for size. And I'll add this to our lingo here. Size for size. Sometimes you hear people say size for size. It just means the same size. Size for size. So this concludes the video. Have some practice. Have some fun, and we will talk again.